Hello! Today I want to show how simple rectifiers relate to HVDC. This is probably the simplest rectifier you can get. It's a source, 100 kilovolt peak. Then you have an impedance of the source, and you have a diode and a load. So you see that the load only gets half cycle current, and the rest is blocked by the diode. If we want to get both half cycles rectified, then we build a diode bridge. This is the diode bridge. And let's see the difference. Here you can see, so this time we do not have only one half cycle per full cycle, we have two half cycles. So the bridge is much more efficient than a single diode. Let's have a closer look at the diodes. So on are normally these two diodes, whereas at the same time these other two diodes are off, and vice versa. If I want to have a smoother current through the load, I add a reactor. Put the reactor to 1 Henry to start with, and you will immediately see how much smoother the current is now through the load. And if I even increase the value of my reactor, you can see that I can further smoothen the current through the load. You can observe that at the point in time where the voltage source is crossing zero, that we have an overlap, so all four diodes are conducting at the same time, so it's a kind of a short circuit. So the source sees a short circuit, and this time is called commutation, and this is the time where the current is handed over from one pair of diodes to the next pair of diodes. The time needed for commutation mainly depends on the source impedance. So you can see if I increase the source impedance, this time gets longer, and vice versa. If I decrease the source impedance, the time gets shorter. If I want to control the current, I have to change my load resistance. And if I would like to change the current through the load without changing the load, because the load would be given, then I would need to replace the diodes by means of thyristors, and this is what I will do now. So, and if I let it run now, I should be able to control the thyristors all together, and you can see I can control now the current through these four thyristors. And if I watch the current through the thyristors, I get also some interesting insider views. I just look at these two because the other two are the same. So you see, now I can look at what happens at the thyristors, and you also see the commutation between the pairs of thyristors. I can increase or decrease this commutation time. You can see here. I can further smoothen the current by increasing the reactor at the load side. If you want to know how to apply the thyristors and control them as a group, I refer to the user's guide. You can find it under this item here, user's guide. Then you get to the user's guide on internet, and you can go to thyristors, and there you see the whole story, how to apply thyristors. Okay, so first of all, you have to set up a reference for all the thyristors, preferably the source, and then you have to group them all together so that you can control them as one, as if they were one. So you can see just shifting one shifter controls all the thyristors, so they have the same position of all the shifters. So that's the magic of this program. This is now a single-phase rectifier. Large rectifiers would be based on three-phase, but the principle is the same. I want to show you now simply how you could build an HVDC connection based on one single phase, just based on these simple rectifiers shown here. So this is now this mini HVDC. So here you have the converter, and here you have the inverter. So the power is flowing from here to here. Here you have the line with something like 2 millihenries, and then you have a line resistance, which which is a couple of ohms. And you control the power flow by controlling the voltages at both ends, and you do that by means of the thyristors. And you can now control the thyristors altogether. So you control the thyristor on the sending end. So you have to be a little bit careful, otherwise you destroy the commutation. This is a problem in real controls too. And here you are on the other side, so you can control really the power flow. And you can see the power which is going into the receiving end. So this is power which is mainly positive, and the sending end is then negative. If you want to reverse the power flow, you have to carefully start to change the trigger angles. Here you see a circuit which would be closer to a real HVDC transmission. So what you see is that we have a 12 pulse converter, meaning that you have two transformers in series, one in delta, one in star connection, and this on both sides. And then of course you have all the valves, which are the number of the valves is much higher than before. So this is really at the limit of what you can simulate with this simulator for the time being. This is just to give you an impression. So here you see the current, the DC current. This is the green line you can see on top there. And here you see the power at the receiving end. And on the other side you see the power at the sending end. And also here you can start to move around the thyristor firing angles, so in order to change the power transmission. To get practical hands-on experience, go to this web address here. You will find an online circuit simulator, and you can play around with your own circuits.